Externally bonded FRP composites are cost-effective systems for dealing with rehabilitation. They handle deterioration caused by environmental effects, damage caused by impact, and higher load demand brought on by more severe code requirements, especially in the seismic field. They also can address changes in the use of structures and higher strength and ductility demands to correct design or construction errors. The contractor will need to provide the correct concrete surface profile, or CSP, for the substrate being treated with FRP, according to all project-specific documents drawn by the design professional. The adhesion of the FRP system to the substrate is typically the most critical element of the design. Outside of rare applications that are not considered bond critical, such as when a member is completely encapsulated, FRP systems require a properly prepared substrate to ensure bond performance. Surface preparation is dependent on the type of FRP material specified. Regardless of the application, a CSP of 3 to 5 is generally required in the project specifications. A CSP of 3 to 4 is generally used for fabrics, and a CSP of 4 to 5 is used for laminates. Grinding may be necessary for treating all protrusions and form lines, as well as for rounding off outside corners to a radius of a ½ inch or 12 millimeters if they are covered by FRP. This will avoid damage to the FRP fibers and provide an even contact between the substrate and the FRP. Trace all locations of FRP using the engineering plans and drawings before beginning the work to ensure proper placement of the carbon fiber products. Precision in the placement of carbon fiber is critical to its success and has been precisely calculated by the design professional. All deviations may have consequences to the structural performance of the system being installed. Part of the preparation process is pre-cutting the necessary quantity of carbon fiber, in this case the fabric, to the proper length and size. This avoids unnecessary delays that could cause the resins to harden before you have a chance to install the fabric. To preserve the line tracings that mark the location of the FRP installation, masking tape may be used before installing the primer and paste. This will allow the markings to remain visible for the following steps. MapeWrap Primer 1 is used in order to consolidate and prime the substrate, which optimizes bonding performance for the other components of the MapeWrap composite system. MapeWrap Primer 1 is installed with a 3/8 inch or 10 mm nap roller at a rate of 150 to 190 square feet per US gallon, or 3.67 to 4.65 square meters per liter. Very porous substrates may require a second coat after the first coat has been completely absorbed. Once prepared, MapeWrap Primer 1 has a working time of 90 minutes. MapeWrap 11 and MapeWrap 12 should be mixed thoroughly according to mixing instructions on the technical data sheet. MapeWrap 11 and MapeWrap 12 can be used to provide better adhesion for embedding heavyweight fabrics. When using MapeWrap 11 or MapeWrap 12 to smooth and level a substrate, apply it at a thickness of 1/32 to 1/6 inch or 1 to 4 millimeters. Apply the adhesive while the primer is still wet or tacky, and then use a flat trowel to smooth the surface and remove any imperfections. MapeWrap 11 is primarily used in cooler climates from 41 to 73 degrees Fahrenheit or 5 to 23 degrees Celsius. It has an approximate working time of 40 minutes at 73 degrees Fahrenheit or 23 degrees Celsius. MapeWrap 12 will provide a longer pot life and is also suited to temperatures from 73 to 86 degrees Fahrenheit or 23 to 30 degrees Celsius. It has an approximate working time of 60 minutes at 73 degrees Fahrenheit or 23 degrees Celsius. MapeWrap 21 is a low-viscosity 100% solids epoxy saturant specifically designed to wet out fibers. It can be used with manual or automatic saturation equipment. Once mixed, MapeWrap 21 will allow 20 to 60 minutes of working time in a temperature range of 50 to 86 degrees Fahrenheit or 10 to 30 degrees Celsius. In this case, a homemade saturation table is used to saturate or wet out the fabric. Once the fabric appears uniformly saturated with resin, it can be rolled onto a pipe or cylinder to facilitate its transportation and handling, ensuring that the fibers are not damaged by folding or pulling. Care is taken to place the saturated fabric in the correct position and then unroll it along the location marked by tracings or tape lines. This ensures that the fabric remains on a straight plane by pulling the material as tightly as possible without having it slide. Once the fabric is installed onto the substrate, follow up by using a ribbed roller to ensure the removal of any air pockets trapped beneath the fabric, which could weaken the overall system. Place an additional coat of MapeWrap 21 by roller until the installed fabric shows a glossy surface, and then use the ribbed roller again as often as needed. If additional layers of carbon fiber fabric need to be overlapped, it is often more effective to do so immediately while the previous resin is still fresh. This ensures a better bond between layers. After several passes using a ribbed roller, another light coat of MapeWrap 21 is applied onto the surface. Immediately afterward, a saturating broadcast of clean dry quartz sand, 20 to 30 mesh in size, is applied to the surface. This sand broadcast will provide a mechanical bond for future installations of any decorative paints or any modified cementitious acrylic or polyurethane protective coatings that may follow, giving the final aesthetic appearance required by the specifier. MapeWrap 31 saturating resin is mixed and used for a dry layup installation of fabrics. When installing with the dry layup method, the installer uses a brush or a paint roller to apply a uniform first coat of MapeWrap 31 over MapeWrap Primer 1 or optional fresh MapeWrap 11 or MapeWrap 12. Immediately, he will lay out the dry fabric. Next, he will use a plastic spatula to remove any wrinkles or creases. After applying the MapeWrap Uniax fabric and removing any creases, apply a second coat of MapeWrap 31 by brush or roller. Work the fabric with a ribbed roller to help the resin saturate the fabric and to remove any air voids that may be trapped behind the fiber. While the MapeWrap 31 is still wet, the installer will sand broadcast oven-dried silica sand that is 20 to 30 mesh in size. This sand broadcast provides a mechanical bond for other finishing materials if needed. The Carbo plate system incorporates pre-cured carbon fiber laminates manufactured through an innovative pultrusion process that places protective plastic film on both sides of the laminate. This eliminates the need to wipe down the laminates with solvent. With the Carbo plate system, plates or laminates are bonded to the concrete surface elements with a thixotropic epoxy adhesive, MapeWrap 11 or MapeWrap 12, to repair, upgrade, or increase the flexural strength of beams or slabs. As with the other carbon fiber products, MapeWrap Primer 1 is installed onto the substrate to consolidate and improve bonding of the Carbo plate products. The MapeWrap 11 or MapeWrap 12 serves as a leveling product as well as an adhesive for bonding the Carbo plate laminates to the substrate. Once the primer becomes tacky, MapeWrap 11 or MapeWrap 12 is installed onto the substrate at a thickness of 1/32 to 5/64 of an inch, or 1 to 2 millimeters. The installer will prepare the Carbo plate laminate by peeling back the plastic film and then applying an even coat of MapeWrap 11 or MapeWrap 12 at a thickness of 40 mils. Install the Carbo plate, applying constant pressure over the whole surface to ensure full contact of Carbo plate to the epoxy adhesive. Remove any excess resin adhesive with a trowel. Once the resin has hardened sufficiently without worries of the Carbo plate moving, the apparent second layer of plastic film can be removed from Carbo plate. To protect Frp resins from deterioration by UV rays, speak with a MAPEI representative about using products from MAPEI's Elasticolor line or polyurethane line.